Welcome to Brain Vision.
All right, here's our tube before and after the experiment. So originally we have a pressure of P naught in the tube because there's no water in it, so it's just the pressure of, I guess, the atmospheric pressure. 1.01 times 10 to the 5 pascals. And then we have this new pressure here in the tube, air pressure. This is the pressure of the air. I'm just going to say P1, and we need to find this value. Okay, so we know that the temperature and the number of air molecules, air moles of air, remains constant in the tube before and after the bird enters and leaves the water. So we can rearrange our ideal gas law into the following equation, where P naught V naught is equal to P1 V1, and we want to find P1, so we can rearrange. P1 is equal to P naught V naught over V1, which we can plug in our numbers. P naught 1.01 times 10 to the 5 pascals, our original volume. It's just going to be the area of whatever the base of this tube is, times the height, which is 0.065 meters, over the initial volume, or the volume afterwards, which is again the same area of the base, times, well, we want the air, right? And it tells us how much is filled with water, so it's going to be 0.0065 minus 0.027 to get meters, and to find how much air we have. Now you'll find the area of the base will cancel, and so the pressure in the tube afterwards is going to equal 1.73 times 10 to the 5 pascals. Now we can turn to our buoyancy equation. P1 is equal to P naught plus density GH. Now we know the density of seawater is equal to 1,029 kilograms per meters cubed. So we just plug in our numbers here. P1, we found 1.73 times 10 to the 5 pascals. P naught we had before, right? 1.01 times 10 to the 5 pascals, plus our density, 1,029. Gravity, 9.8 meters per second squared, and then H are essentially our depth. And if you plug everything in, right, solve for H, you should find that H is equal to 7.12 meters, which is how far the bird dove.